Welcome back. Today we are talking about area under the normal curve. So we have talked about what is a normal curve, what does it mean for us. We've talked about the 68, 95, 99.7 rule. We've also talked about z-scores, but we kind of stopped there. So now we're going to talk about, well, what does that mean when we put it in context? I mean, we talked a little bit about it's this many standard deviations within the mean, but we haven't really talked about, well, what does that mean in terms of probability? So here's where we're going to tie it together. All of our units, when we're talking about area underneath the normal curve, they are being standardized. So we're always going to have 0 in the middle. Before, we could have had, like, if we had a mean of 15 and a standard deviation of 3, we would always put like we would have had 15 in the middle. But everything is being converted to the z-scores. So now everything, we're always going to start with 0 in the middle. So how do we make this work? Number 1, draw the normal curve. Again, 0 is in the middle. Number 2, whatever z-score you were trying to find the area under, you are going to mark it on the curve. You are going to draw a vertical line through the curve. You will shade the area that's being asked for. You'll use the table to find the z-score and its corresponding area. And then the last step, don't forget, the whole purpose of standard normal curves and interpreting data is, well, what does that tell us? So you need to tell us, what does the decimal value mean? So first example, we're shading the area under the curve that corresponds with z is less than 1.25. So I'm going to look on the horizontal axis. I see zeros in the middle. Great. And if it helps you to put these numbers in as well, go for it. It will always be 1, 2, 3, and -1, -2, and -3. 1.25, that's about a quarter of the way past 1. So you can draw a vertical line through it. And then you're shading all this area that's to the left. Okay, so we're done already with steps 1 through 4. Step 5, use the table to find the z-score and its corresponding area. So you have this PDF saved in Schoology, but we are looking for 1.25. So this table looks big and confusing, and truthfully, you're right. So kind of break it down for you. We are looking right now at z is less than 1.25. I'm going to highlight exactly what it is we're doing. The first thing you want to do, you want to look for your first two numbers, 1.2. That's going to be on this column on the left-hand side. So I see 1.2. I'm just going to highlight the whole row for right now. The second thing we're doing is looking for the number that's in the hundredths place, which is 5. So 0.05. And then go down. So right now, I can see where the green and the yellow meet was here at 0.8944. So I'll come back to the question. 0.8944. What does the decimal mean? It means that 89.44% of the data is less than or to the left of 1.25. So less than 1.25 standard deviations. All right. Let's try again. So our job here, we're going to shade the area under the curve that corresponds with z is less than negative 1.5. So again, you want to find negative 1.5. So 1, 2, 3, negative 1, negative 2, negative 3, negative 1.5 or 1.50. Be right in between negative 1 and negative 2. And again, it's less than. So we shade to the left. So if you're using your table again, this time we're looking for the negative 1.5. So always look on the left-hand side first. I see the negative 1.5, and for us, it's negative 1.50, so that's nice. It's just the first number out there, 0.0668. So what does that mean? 6.68% of the data is less than z equals negative 1.5. And again, that kind of depends on your data set. So that could mean, like, let's say you're talking about inches again. Whatever data value represents z equals negative 1.5, that would mean that everything that has a z-score less than negative 1.5 is going to be smaller than that number. And it's only going to be 6.68% of data that's smaller than the corresponding z-score. So what happens when we're talking about greater than? What if z is greater than negative 0.75? Look at the table again. Look for negative 0.75. And because 0.5 is in the middle, I'm just going to highlight the whole row. I'm going to follow the 0.05 down, and I can see we have 0.2266. But we want greater than. So I'm going to write the number down. But what we're looking for, instead of what is to the left of this number, we want what's to the right of this number. So mark where it is on your normal curve. Shade the area. And this time, subtract the number from 1. Anytime you're going to the right, you want to do 1 minus whatever numerical value corresponds with your z-score. And for us, we should be getting 0.7734. So then what does that mean? Again, you want to talk about this decimal in terms of percents. So 77.34% of data is greater than z equals negative 0.75. Okay, so now we're going to look at shading the area under the curve that corresponds with z is greater than 2.44. So you can make your scale again. Again, 0 is always in the middle, and it always goes from 1 to 3. Or I should say, sorry, negative 3 to positive 3 using a scale of 1. look for 2.4, which is about halfway in between 2 and 3. We want z is greater than 2.4, so you want to shade to the right of z. And then go back to your z-score table and look up a z-score of 2.4, which again is nice because it's really close, 0.9918. Come back here. But again, that would be nice if we were just looking at to the left of the data. But we care about what is to the right of it, so you have to subtract this number from 1. And we should be getting 0.0082. So what does that mean again in terms of percents? So 0.82, or approximately 1% of data is greater than z equals 2.4. So again, going back to inches, if you had some, let's say, for whatever example we're looking at, 70 inches corresponds with a z-score of 2.4. That means that about 1% of the data would be taller than 70 inches. So now we're going to look at a case where you need to go in the middle. We have z is in between negative 0.75 and 0.24. So start off, find those z-scores on your horizontal axis. Draw a vertical line, shade in the middle this time. So we can use our table to look up those values, but we already calculated this, the percentages or the area to the left of these z-scores. So all we have to do is take the corresponding area for z equals 2.4 and subtract the corresponding area for z equals negative 0.75, which we've already calculated. We did those in previous examples. I'm going to scroll up right here. We already calculated z is less than 2.4, so that's 0.9918. And then if I flip back a page, negative 0.75, that was the very last example we did, and we got a z-score of 0.2266. So we subtract those values, and we get and then again, the question is saying, what does that decimal value mean? Again, turn it to a percentage. And it means that 76.52, or about 77% of data, falls between z equals negative 0.75 and z equals 2.4. All right. That was how to do it by hand. So the next way I'm going to show you is how to do this on a graphing calculator. So for now, I will sign off, and you can watch the next video for how to do this on a graphing calculator.